We're going to go over our entrance slip over ionic compounds number 2. So let's start out by looking at copper 1 carbonate. Like we always do, folks, use a different color so I can see your corrections. Okay? I do go through and look at all these entrance slips because I like to see what is going through your minds and why you are missing things, if you are. Okay, so it's a good way for me to check your stuff and see that you are getting what we are actually doing, so that we're thumbs up here. Now, copper 2 carbonate. Some things I look at when I see this. I see a Roman numeral here, so that tells me that copper is multivalent, and it tells me that I am dealing with copper 1+, because it's Roman numeral 1. I look at this and I see I have carbonate. Okay, that ATE tells me that I need to find this guy on my ion sheet. So when I'm looking at carbonate, the ATE, I see that it is CO3 2-. Now, whenever I have a polyatomic, I always put this box around it. That box tells me that when I finish, I better still have CO3. Because if I don't have CO3, I've changed it to something different. I look and I say, okay, here's a 1+, here's a 2-. My charges are not equal. So I'm going to need another 1+. So here's my other 1+. So when I write this out, I need 2 coppers to go with my carbonate. Final answer. We okay with that? My next one, strontium oxalate. Okay, I don't see a Roman numeral, so that's telling me that strontium is not multivalent. I look at strontium. Strontium is an alkaline earth metal. So I can see that strontium is SR, and it's going to be 2+. Once again, oxalate, I see that ATE ending. That ATE ending tells me I'm going to look at my PAL, my polyatomic ion list. And when I find oxalate on PAL, it is C2O4 2-. Once again, I put my box around so I know that I don't change that C2O4. I look at my charges. 2-, 2+. Am I equal to 0? Absolutely. So I just put them together. Strontium oxalate. Final answer. Now, do you see any charges in that box? Okay. No, there's no charges there, but we know what the charges are, right? Because we know strontium's a +2, and we know oxalate's a -2. Charges aren't there, but we can see by the formula what those are. Iron 3 fluoride. Roman numeral, so that tells me that this iron is multivalent. We have iron 2+. Okay. I see an IDE ending right here. IDE ending tells me that most probably that is a monoatomic. Okay? Fluorine is a halogen, so I can see that fluorine on my periodic table, fluorine is going to gain 1 electron, so it's going to be a -1. If you would look on the monoatomic anion list, fluorine would be on it, saying -1. So as I'm looking, are my charges equal? They are not equal, so I need another 1-. Okay, so now they are equal. So as I write out my final answer, I have iron and I have 2 fluorines, so FeF2 is iron 2 fluoride. Now we're going the next way. I have NiCrO4. I need to write the name of that formula. So I look and I start with my positive, Ni. So I know that Ni is nickel. I look at my periodic table because I need to know whether nickel is multivalent or not. And that when I look up nickel, it takes a +2 and a +3. So I'm going to need a Roman numeral. So I put my brackets in there, my parentheses in there, so I don't forget my Roman numeral. And I need to find out what this CrO4 is. So I look at my polyatomic ion list for CrO4, and it is chromate. Now, my CrO4, okay, this whole thing right here takes a 2- charge. So if that is 2-, that tells me that this nickel better be 2+ in order to get my sum of my charges to be 0. So that tells me which nickel I have. I have nickel 2+, so I put the Roman numeral 2. So my final answer here is nickel 2 chromate. My final one, ladies and gentlemen, NH4 parentheses 3 P. Now, as I look at this, I see this NH4. That's one I told you you have to just memorize and know that NH4 is the ammonium ion. The ammonium ion. Now, with ammonium, I never use a Roman numeral, okay? So I don't even have to worry about that. So I have ammonium and P, okay? P. So I look on my ion list, and I find where on my monoatomic anions, I find that P is phosphide. That IDE ending tells me it is monoatomic. Okay? So, final answer, ammonium phosphide.